A parabola is a graph of a quadratic equation, and a quadratic equation is any equation where the highest power of x is x squared. Now, this video looks at graphing this form of quadratic equation. All of these forms over on the right here are all covered in video 1. In graphing this form of quadratic equation, there are 4 things that we will normally find. They are the Y-intercept, so that is where the parabola crosses the y-axis. The X-intercept, which is where the parabola crosses the X-intercept, and these are also called the roots or the zeros of the equation. The axis of symmetry, and the vertex, also called the turning point. So let's use an example and find these 4 things. So the example I'm going to use is y equals x squared minus x minus 6. So the first thing we're going to find is the y-intercept. Now, if you think about a graph, this is your x-axis and your y-axis. We are looking to find where the parabola is going to cross the y-axis, and that will be the y-intercept, that value. Now, the one thing that we know at this point on the graph, the x value is 0. We don't know where on the y-axis it will be, that it will cross, but we know that wherever it is, the x value at that point is going to be 0. Knowing that x equals 0, we simply now substitute 0 into our equation. So we get y equals 0 squared minus 0 minus 6. So y equals minus 6. And that will be the point at which our parabola will cross or intercept the y-axis. The next thing we're going to work out is we're going to work out the x-intercepts. There may be 1, 2, or there may be none. But with a quadratic equation, the maximum x-intercepts we can have is 2. The number of possible x-intercepts is always equal to the highest power of x in an equation. Now, similar to looking at the y-intercept, if we think about our x-intercept, we're looking at where the parabola is going to cross the x-axis. And we don't know where on this axis it will be, but the one thing that we know is that the y value at this point or points will be 0. So for the x-intercepts, we know that we have a value of y is equal to 0. So we now substitute y is equal to 0 into our equation, and we get 0 is equal to x squared minus x minus 6. And this is now similar to solving our quadratic equation. We can use either the factor method, completing the square, or use the quadratic formula in order to solve it and find the values of x that will now satisfy this equation. This is a fairly easy one, and I can see by inspection that I'm going to have factors of minus 6 of plus 2 and minus 3. So my equation is going to become x minus 3 times x plus 2. So that was factorizing just by inspection because it was a fairly easy one. You can also use the cross method, and there is a video to show you how to do that if you would like to know how. So solving this now, we have either x minus 3 is equal to 0 or x plus 2 is equal to 0. This gives us a solution of x equals 3, and this one gives a solution of x equals minus 2. So we have 2 x-intercepts in this parabola. We've got x is 3, so there, and also x is minus 2. The next thing to work out is the axis of symmetry. And this is sometimes abbreviated to AOS. Now, based on our equation y equals ax squared plus bx plus c, our axis of symmetry is equal to minus b over 2a. So using our original equation, which is y equals x squared minus x minus 6, then we know that a is the coefficient of x squared, so that's 1, and b is the coefficient of x, and that's minus 1. So our axis of symmetry is equal to minus b, which is minus 1, over 2 times a, which is 1. So that works out to be 1/2. So that is x equals 1/2 is the equation of the line for the axis of symmetry. And finally, to work out the vertex, which is the turning point. Now this always happens along the axis of symmetry, and we know that the axis of symmetry is when x is equal to 1/2. So now it's simply a case of taking our equation and substituting x equals 1/2 into the equation to find the y value, and we then have the coordinates xy of the vertex. So let's go ahead and do this. So we've got 1/2 squared minus 1/2 minus 6. This gives us a y value of y equals minus 6 1/4. So we have our vertex at coordinates x is 1/2 and y is minus 6 1/4. Now this is also our maximum or our minimum value of y on our graph. Let me just explain why. If it's a concave up graph like this, then the vertex here is the minimum value of y. If it is a concave down graph, then the vertex is the maximum value of y. Let's put all the information together for our equation for y equals x squared minus x minus 6, and let's sketch our parabola. So the first thing that we worked out was that the Y-intercept was at y equals minus 6. We worked out that our X-intercepts were at minus 2 and plus 3. And remember, they are also called roots or zeros. That's a term that you're going to need later on. Our axis of symmetry was at x is equal to 1/2. And this is the line about which our parabola is symmetrical. And it's also the line on which our vertex sits. And our vertex was at the coordinates x is 1/2, y is minus 6 1/4. So our vertex is down there. Now it's a case of just drawing in our curve, and I'll try very carefully to make it as neat as possible. The little arrows to show that it does extend. And look, I missed actually putting it through the minus 6. I was a little bit off there, but anyway, that is sketching our, I missed the minus 2 bit too, but that is sketching our parabola for this equation, this quadratic equation here. So those are the steps that you take to sketch your parabola. And work through some examples now so that you will have a bit more experience with it. And the 3 I'm going to do are y equals x squared minus 2x minus 3. I'm almost going to do y equals 2x squared plus 4x plus 3. And the last one I'm going to do is y equals 4x minus x squared. And all of these three will illustrate something slightly different in sketching parabolas. Okay, let's take the first one then. So we've got y equals x squared minus 2x minus 3. First thing we're going to do is our y-intercept. Remember, at the y-intercept, x is equal to 0. So we simply substitute 0 in, and we get 0 squared minus 2 times 0 minus 3. So we have a y-intercept of y equals minus 3. The next thing I'm going to work out is the x-intercept. And remember, for the x-intercept, the condition is that y is equal to 0. So I substitute y as 0 is equal to x squared minus 2x minus 3. I'm going to factorize this, and that's going to factorize. I can do that again by inspection. So that is going to be minus 3 and x plus 1. So we've now got x minus 3 is equal to 0, or x plus 1 is equal to 0. That leaves us with two solutions for x, two x-intercepts, or roots or zeros. So x is equal to 3, or x is equal to minus 1. Now for the axis of symmetry. And remember, for the axis of symmetry, x is equal to minus b over 2a. In this case, our b is minus 2. So it's minus 2 over 2 times a. And our a, our coefficient of x squared, is just 1. So we have got x is equal to 2 over 2, so it's simply 1. And the last step is our vertex. And for our vertex, we simply substitute in x is equal to 1, because the vertex lies on the axis of symmetry. So we're simply finding the point of the parabola that lies on the axis of symmetry. So we substitute in x is equal to 1, so it becomes 1 squared minus 2 times 1 minus 3, which gives us a value of y of 1 minus 2 minus 3 is minus 4. So our vertex is coordinates 1 minus 4. We now have enough information that we can sketch this. So I'm going to do this over here. And we have a y-intercept of minus 3. We have x-intercepts of minus 1 and 3. We have an axis of symmetry of x is equal to 1. So our 1. And our vertex is on 1 minus 4. It's just down here. And I will give it a go to try and sketch it and get through all of those points. There we go, that's a better one. Arrows show that the curve continues, and that is our parabola for our equation y equals, should write it up here, y equals x squared minus 2x minus 3. Okay, on to the second one, and this is going to show something quite different. So we've got y equals 2x squared plus 4x plus 3. So we start off the same. The first thing we're going to do is our y-intercept. For our y-intercept, remember, x is equal to 0. So we simply substitute that in. And we get a y-intercept of y equals plus 3. The next step is to work out the x-intercept. So this means when y is equal to 0. So we substitute in 0 equals 2x squared plus 4x plus 3. Now this isn't an easy quadratic equation to solve by factorizing, either by inspection or the cross method, or completing the square. So I'm going to resort to using the quadratic formula to solve this one. So the quadratic formula, if you remember, is x is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. And our a, b and c are our coefficients for x squared, for x, and just the number at the end. So we can substitute those numbers in. b is 4, that's minus 4, plus or minus the square root of 4 squared, minus 4 times a, which is 2 up here, times c, which is our 3 here, all divided by 2 times a, which is 2. Now if we continue to work this out, this gives us a value of minus 4 plus or minus the square root of. Now, we've got 4 squared is 16, minus 4 times 2 is 8, times 3 is 24. So we've got 16 minus 24, which is minus 8, all divided by 4. Now this is where we run into a problem because we cannot take the square root of a negative number. So in this case, there is no solution. So there are no x-intercepts, and it means that our parabola does not cross the x-axis. We can still continue now to work out the next thing, which is the axis of symmetry. And x is equal to minus b over 2a, and that is equal to minus 4 over 2 times 2, which is equal to minus 1. I'm just going to move on to the right side of the page now to try and keep all the working on one page. So we have an axis of symmetry of x is equal to minus 1. We can now continue to work out the vertex, which is point on the axis of symmetry where x is equal to minus 1. So we simply substitute minus 1 in for our x. And we get y is equal to 2 minus 4, which is minus 2, plus 3, which gives us y is equal to 1. So our vertex is at x is equal to minus 1, y is equal to 1. We can now go ahead and sketch this with the information that we've got. I'm going to put my x-axis down very low because I know that we had no solution, so the parabola is not actually going to cross the axis. So we've got y-intercept of y is equal to 3, no x-intercepts, axis of symmetry of x is equal to minus 1, and our vertex at minus 1, 1. So that is going to give us a parabola that looks like this. And as you can see, it doesn't cross the x-axis. Okay, just better put all the labels on so it's all done correctly. And that's our graph of our parabola. And onto our last example, number 3. Y is equal to 4x minus x squared. Now when you first look at it, that's very confusing. But if you rewrite it as y equals minus x squared plus 4x, then you can see it's of the quadratic equation form without the number at the end. And we can go through exactly the same steps to graph this. The first thing I'm going to note, though, before we actually start working out the intercepts and the axis of symmetry in the vertex, is that we have a minus before the x squared. So that means it's actually going to be the concave down shape parabola. Okay, so first of all, let's work out our y-intercept. And this is when x is equal to 0. So we simply get y equals minus 0 squared plus 4 times 0, which is y is equal to 0. The next one is our x-intercept, and that is when y is equal to 0. So we substitute 0 in for our y, and it's minus x squared plus 4x. Now we can factorize this very easily by simply taking an x, which is common to both, out of each term. So we get minus x here plus 4 in our bracket. And if we solve this, then we get a solution of either x is equal to 0 or minus x plus 4 is equal to 0, which simplifies to x equals 4. So we have two x-intercepts at x equals 0 and x equals 4. Now for our axis of symmetry, and that is when x is equal to minus b over 2a, and that is looking at our equation up here. Our a is the coefficient to x squared, so that's minus 1. Our b is the coefficient of x, so that's 4. So we've got minus 4 over 2 times minus 1. And that works out to be minus 4 over minus 2, which is just 2. So our axis of symmetry at x equals 2. And finally, to work out the vertex, that is the y coordinate that we need now for when x is equal to 2. So we simply substitute in x is equal to 2, and we've got minus 2 squared plus 4 times 2, and we've got y equals minus 4 plus 8 gives us y equals 4. So our vertex is at x is equal to 2, y is equal to 4. Okay, we can now sketch this. And let's put on the information we've got. We've got a y-intercept at y equals 0. That's there. We have two x-intercepts at x equals 0 and x equals 4. So that's our x equals 0 mark that we've already got there, and that's our x equals 4. Our axis of symmetry is at x equals plus 2, so that's straight down the middle. Notice the axis of symmetry is always right in the middle of the x-intercepts, the zeros or the roots. So it's right smack in the middle. But you should always work it out this way, just to double check you haven't made a mistake anywhere. Finally, our vertex is at 2, 4, so 2, 4. And remembering that it's a minus x squared graph, so it's a concave down shape, we can draw our parabola like this. And remembering to label it, y equals minus x squared plus 4x. Or we could have put the original label on, y equals 4x minus x squared. Doesn't actually make any difference. So using these steps, you should be able to graph any parabola which is in the form ax squared plus bx plus c.